An inductor is a very interesting device. When simply connected to a DC supply, it acts as a magnet. It has many applications in all engineering disciplines. But take a logical look in physics behind inductors. A current-carrying conductor produces a magnetic field around it as shown. But to do an interesting experiment, let us bend a wire as you bend a wire, a magnetic field lines interact with each other and producing interesting magnetic field as shown. This magnetic field pattern is similar to that of permanent magnet. Similarly, by increasing the number of loops, we can increase the magnetic flux. We can also increase magnetic flux by increasing the current to the coil. A constant called inductance connects between the magnetic flux and the current value. The value of inductance depends purely on the geometry of the coil. Now, the most important part of this video, what will happen if the current through the coil changes? When the current changes, the magnetic flux that the coil produces also changes, which means we need to study the effect of this carrying magnetic flux. To study the effect of this varying magnetic flux, we need to introduce Faraday's law. The great scientist Faraday said if the magnetic flux changes across the loop, it will induce an EMF. Across it here, you can see that the permanent magnet approaches or leaves the loop, it will induce an EMF across it. This results a current because the moment of permanent magnet causes a varying magnetic flux on the loop. Now let's apply a Faraday's law, inductor connected across in AC power supply. According to Faraday's law, the varying magnetic flux that the AC power source produces will definitely produce an EMF across it. This EMF is known as back EMF, and this phenomenon is called self-induction.